Hello, dear students. Let's move on in molecular orbital theory. Let's see the conditions for the combination of atomic orbitals. The conditions that are required for the linear combination of atomic orbitals are as follows, and you have to remember that the formation of molecular orbitals takes place only if these conditions are being satisfied. So number 1 is the combining orbitals must have same or nearly equal energy, means 1s can combine with 1s only, 2s will combine with 2s only, means the energy should be equal of the combining atomic orbitals. Okay, and only those atomic orbitals overlap to form molecular orbitals which have nearly equal energy and have proper orientation. We will not make the 1s combining to 2s or 2s combining to 2p, means it should be very clear that equal energy atomic orbitals will combine. 1s will combine with 1s, 2s will combine with 2s, 2p will combine with 2p. Okay, next criteria is the combining orbitals must have the same symmetry about the molecular axis. The same means the by convention z-axis is taken as the molecular axis. It is important to know that atomic orbitals of nearly equal energy do not combine if they do not have same symmetry. For example, for homodiatomic molecules such as nitrogen, oxygen, fluorine, etc., 1s atomic orbital of one atom can overlap with 1s atomic orbital of another atom. 2s can overlap with 2s and 2pz can combine with 2pz. Okay, so orientation also matters. 2pz orbital cannot combine with the 2px or 2py orbital of other atom. Do remember, 2pz orbital cannot combine with the 2px or 2py orbital of the other atom. It is because they do not have same symmetry. 1s orbital cannot overlap with 2s orbital because the energy of 2s orbital is appreciably higher than the 1s orbital. Thus, only a limited number of combination of atomic orbitals are possible. Next is combining orbitals must overlap to the maximum extent, means the atomic orbitals which are combining. The combining atomic orbitals must overlap to the maximum extent. Greater the overlapping, greater is the electron density between the nuclei of a molecular orbital and stronger is the bond formed. Next condition, the shapes of molecular orbitals formed depend upon the type of atomic orbitals taking part in overlapping. As you have seen, there are two types of molecular orbitals. I will discuss this again. Two type of molecular orbitals. Psi A plus minus psi B. Okay, for bonding molecular orbital, psi B is equals to psi A plus psi B. I hope you remember. And for anti-bonding molecular orbital, psi A is equals to psi A minus psi B. So you can see that bonding molecular orbitals are formed by the additive effects, whereas anti-bonding orbitals are formed by subtractive effect. The probability of finding the electron in bonding molecular orbital increases, whereas it decreases in the anti-bonding molecular orbital. Electrons placed in molecular orbitals hold the nuclei together and stabilize a molecule. Therefore, bonding orbitals always possess lower energy than the parent atomic orbitals. This is your parent atomic orbital. Okay, you can see that the bonding molecular orbital is lower in energy. Lower in energy. So electrons placed in molecular orbitals hold the nuclei together and stabilize a molecule, and therefore bonding orbitals always possess lower energy than the parent atomic orbitals. In contrast, the electrons placed in the anti-bonding molecular orbitals destabilize the molecule and possess more energy than the parent atomic orbitals. So now let's see types of molecular orbitals. According to the molecular orbital theory, there exist three primary types of molecular orbital that are formed from the linear combination of atomic orbitals. These are anti-bonding molecular orbitals. The electron density is concentrated behind the nuclei of the two bonding atoms in anti-bonding molecular orbitals. This result in the nuclei of the two atoms being pulled away from each other. These kinds of orbitals weaken the bond between two atoms. In the case of non-bonding molecular orbitals, due to a complete lack of symmetry in the compatibility of two bonding atomic orbitals, the molecular orbitals formed have no positive or negative interactions with each other. These type of orbitals do not affect the bond between the two atoms. Now let's see the formation of molecular orbitals. In atomic orbital in an is an electron wave. Okay, psi, the symbol I am using, you should have understood that it is related to wave. So an atomic orbital is an electron wave. The waves of the two atomic orbitals may be in phase or out of phase. I am saying that they can be in phase. This is in phase, and they can be out of phase also. Out of phase will be this will be out of phase. Suppose psi A and psi B represent the amplitude of the electron wave of the atomic orbitals of the two atoms A and B. When two waves are in phase, so that they add up the amplitude of the wave, psi A plus psi B. This will showing the wave which is in phase. Now case 2, when the two waves are out of phase, the waves are subtracted from each other so that the amplitude of the new wave is psi A minus psi B. You can see that it is out of phase. Okay, so it is subtractive. So what will be the characteristics of bonding molecular orbitals? The probability of finding the electron in the internuclear region of the bonding molecular orbital is greater than that of combining atomic orbitals. The electrons present in the bonding molecular orbital result in the attraction between the two atoms. That's why for the formation of bond, electrons must be present in the bonding molecular orbital. Greater the number of bonding molecular orbitals, stronger the bond will be. The bonding molecular orbital has lower energy as a result of attraction and hence has greater stability than that of the combining atomic orbitals. You will see that if bonding and anti-bonding electrons are equal, no bond will be formed. So electrons should be present more in bonding orbitals for the formation of bonds. They are formed by the additive effect of the atomic orbitals, so that the amplitude of the new wave is given by phi is equal to psi a plus psi b. And they are represented, bonding molecular orbitals are represented by sigma, pi and delta, etc. And how anti-bonding orbitals, why they have higher energy? Actually, the energy levels of bonding molecular orbitals are always lower than those of anti-bonding molecular orbitals. This is because the electrons in the orbital are attracted by the nuclei in the case of bonding molecular orbitals, whereas the nuclei repel each other in the case of anti-bonding molecular orbitals. If we will see the difference between bonding and anti-bonding molecular orbitals, here are a few differences. Molecules obtained from the additive effect of atomic orbital is called bonding molecular orbitals. Molecular orbitals formed by the subtractive effect of atomic orbital is called anti-bonding molecular orbitals. Probability of finding the electron is more in the case of bonding molecular orbital. In anti-bonding, probability of finding electron is less in anti-bonding molecular orbital. There is also a node between the anti-bonding molecular orbital between two nuclei where the electron density is 0. Bonding BMO is formed by the combination of plus plus and minus minus part of the electron waves. ABMO, these are formed by the overlap of plus with minus part. BMO, the electron density in the bonding molecular orbital in the internuclear region is high. As a result, the nuclei are shielded from each other and hence the repulsion is very less. The ABMO, the electron density in the ABMO is in the internuclear region is very low, and so the nuclei are directly exposed to each other. Therefore, the nuclei are less shielded from each other. BMO denoted by sigma, pi, delta. ABMO denoted by sigma star, pi star, delta star. So this was all about the bonding. In my next lecture, I'll take you to draw energy level diagram for molecular orbitals. That will be the most important part. With that only we will be able to calculate the bond order also. And do remember children, this chapter is very important. Many questions are asked in the competitive exams, as well as if you will move further for graduation, any field, either science graduation or technical engineering, this chapter is going to be present there also. So it will be better for you all to clear this chapter properly here in class 11th only. Okay, so do remember this is very important chapter. That's why I'm taking small part in one lecture. In next lecture, I will tell you how to draw the molecular orbital diagrams and how to calculate bond order. Thank you so much, children.